Hello everyone, welcome to the video lecture series on Advanced Separation Process. Myself Jaimin Pandya, Assistant Professor in Chemical Engineering Department of LJ Institute of Engineering and Technology. So let's continue with the chapter number 2, which is a membrane separation process. So in this lecture, we are going to discuss about concept and working of ultrafiltration. Then we are going to discuss about the industrial application of ultrafiltration and various operating parameters and factors affecting on performance of ultrafiltration. Then we are going to discuss about various methods for reduce in concentration polarization in ultrafiltration. So let's start with concept and working of ultrafiltration. Backhold introduced the term ultrafiltration, forcing solution at pressure up to several atmosphere through a membrane prepared by immerging filter paper with acetic acid colloid. Ultrafiltration is a variety of membrane filtration in which hydrostatic pressure forces a liquid against semi-permeable membrane. This is an important separation technology used for the production of pure water in beverage and food industry, biochemical industry and biopharmaceutical industry. Ultrafiltration have a unique ability to purify, separate and concentrate targeted macromolecules in continuous system. In ultrafiltration, suspended solid and solute of the high molecular weight such as 10 raised to 3 to 10 raised to 6 Dalton are retained, while water and low molecular weight solute pass through the membrane. However, ultrafiltration is not fundamentally different from reverse osmosis microfiltration, except in terms of the size of molecule it's retained. In this way, ultrafiltration covers the zone between the other two processes, reverse osmosis and microfiltration. The particle retained range from small macromolecule up to the 500 molecular weight up to colloid particle with diameter of 0.2 micrometer. Ultrafiltration is a pressure-driven separation process in which water and low molecular weight substance permeate through a membrane while particles, colloids and macromolecules are rejected or retained. The primary removal mechanism is the Sykes exclusion, although electric charge and surface chemistry of the particle or membrane may affect the purification efficiency. Ultrafiltration pore rating range from approximately 1000 to 5 lakhs Dalton, thereby making of UF more permeable than nanofiltration 200 to 1000 Dalton. Since only high molecular weight species are removed in ultrafiltration, the osmotic pressure difference across the membrane surface is negligible. Low applied pressure are therefore sufficient to achieve the high flux rate from ultrafiltration tangential flow design to reduce solute accumulate at membrane surface. Tangential flow ultrafiltration device may be a spiral wound cartridge contain various certain square feet of membrane wrapped onto the center core of tube or hollow fiber cartridge containing dozen of thin ultrafiltration membrane fiber. Since fouling is a major problem in ultrafiltration and membrane separation process, which are hydrophilic generally foul less rapidly. There is a competition between the truly stable hydrophobic membrane and less fouling prone hydrophilic ones. Recently, thin film composition ultrafiltration membrane have been in market for high purity water application. The membrane module material must be compatible with the chemical such as hydrogen peroxide used in sanitizing the membrane on a periodic basis. Inorganic materials such as ceramic, carbon-based membrane, zirconium-based membrane have also been commercialized several vendor for ultrafiltration membrane. So there are various modules used in ultrafiltration membrane. Generally, ultrafiltration membrane are available in four basic modules. These are tubular, hollow fiber or capillary, flat sheet and ceramic. Commercial diameter of tube are 5 to 25 millimeter. Tube configuration are characterized by the list of to susceptibility to plug-in, small replacement area and easy of cleaning. Fiber range from few millimeter down to 250 micrometer. The advantage of hollow fiber configuration is a large membrane area per unit volume and possibility of operating with the back pressure for the flashing the module. Flash sheet membrane are most common made into the spiral bound module and plate and frame device. The various membrane characteristics used for the understand behavior of ultrafiltration membrane. The permeability of ultrafiltration membrane is determined by the pore size, pore density, and thickness of membrane active layer. Conventional method of membrane characterization sometimes prove unsuitable for the ultrafiltration membrane. Direct microscopic observation of surface is a difficult and the pores, especially the smaller one, get closed when samples are dried of electron microscopy. On other hand, ultrafiltration membrane contain pores too small to test by the bubble point. So molecular weight cutoff is the most widely used method for the characterization of ultrafiltration membrane. Molecular weight cutoff is the most widely used method for characterization of ultrafiltration membrane. Molecular weight cutoff is a minimum molecular weight rejection being of 90%. To design the membrane, molecular weight cutoff must be taken about the half of lower molecular weight which is to be retained. Ultrafiltration membrane are given nominal rating refer to a molecular weight of test solute that is 90% rejected by membrane under standard condition. Since this does not imply absolute retention by the membrane, this design are sometimes referred to a nominal molecular weight cutoff or normal molecular weight cutoff of ultrafiltration membrane. However, molecular weight cutoff method has some limitations such as more membrane material adsorb protein in pores and also remove protein from permeate by the adsorption in addition that removed by the sieving. Therefore, membrane can be characterized only when they are clean. Ultrafiltration membrane have no sharp distribution of pore size. Some pores are distribution may be a polydisperse. Polarization effect of market protein at the membrane may be alter the measured value and significant accumulation will result in autofiltration. This result is a measure of boundary layer rather than the membrane itself. So these all are limitations for the molecular weight cutoff characterization technique which used for the ultrafiltration. So from ultrafiltration membrane, water can pass through the membrane, monovalent can also pass through the membrane, multivalent ions is also passed through the membrane, and sugar and amino acid is also passed through the membrane. But ultrafiltration membrane can reject protein and polysaccharides and particulates, colloid and bacteria. So ultrafiltration mostly reject the proteins and polysaccharides and particulates, colloid and bacteria. So now let's discuss about various industrial applications for ultrafiltration. Industry such as the chemical and pharmaceutical processing, food and beverage processing, and wastewater treatment employ ultrafiltration in order to recycle, flow, or value to their product. The main attraction of ultrafiltration is ability to purify, separate, and concentrate targeted macromolecules in continuous system. Ultrafiltration does this by pressurizing the solution flow which is tangential to surface of the supported membrane. Some of the important applications of ultrafiltration are in wastewater treatment, treatment of oily wastewater, processing of waste, recovery of electrocoat paint and concentration of latex emulsion. So, to treatment of wastewater and oily wastewater, first we have to require the storage tank, then it passed from the pre-filter where pre-filter of this wastewater and oily water occurs where solid particle is removed by the pre-filter and then it passed from the ultrafiltration unit, then it goes to the secondary treatment or can say that tertiary treatment where we can get pure water. So mostly ultrafiltration used for the pre-treatment before the reverse osmosis or nano filtration. Then it's also used for the treatment of oily wastewater. In oily wastewater emulsion, about 2% of oil. So in oily, so oil in water emulsion is routinely used for the cooling and lubrication of tool and dies during the cutting, forming, grinding of material. The wastewater from this operation contains oil droplet up to submicron. Ultrafiltration is a used in concentrating oil-water emulsion. Membrane retain the stable emulsified oil while the water and very low concentration of dissolved oil and free surface pass through the membrane. It can be concentrate up to the 10% and we can reuse it. Oil in water emulsion contain 10% oil is up to the lubricating and cooling fluid for a process involving single metal sheet. After the process, excess oil emulsion is removed from the can in three stages. At the 60 degrees Celsius water washing cycle, then the rinsing water of a simple production line accumulate the about the 5 meter per day and contain about 0.6 gram per liter of oil. The rinsing of water is proceed in a ultrafiltration unit equipment with the 18 capillary membrane module providing a total of 18 meter of membrane area. In this process, oil is concentrated from about 0.6 gram liter to about 1000 gram per liter and without further treatment recycled into the production line. This virtually oil free filter is fed directly back into the washing cycle. So, this schematic is represent flow diagram of treatment of oil waste water. Second application for ultrafiltration is processing of whey. Whey byproduct of cheese manufacturing is composed roughly 0.6% true protein and 0.2% non-protein nitrogen and 5% lactose, 1% salt and some lactic acid and rest water at pH between 0.3 to 6. It also contaminates at trace amount of casein fines and globules and large population of bacteria. Ultrafiltration retain two principal proteins such as lactabium and lactoglobin along with the Dalton size of 36,000. Then ultrafiltration is also used for the recovery of electrocoating paint. An electrocoating paint is done by the either cathodic or anodic electrodeposition. After the electrodeposition of prime coat, the piece is lifted out from the tank and the undeposited loosely adhesive paint is washed off in spray water. One disadvantage is that drag out loss of undeposited paint. Ultrafiltration allows the recovery of valuable paint, resins and pigments. Ultrafiltration helps maintain the required plant bath control, recover the more than 90% of paint drag out and subsequently reduce the load on wastewater treatment. So this is how the ultrafiltration used for the recovery of electro paint. Then ultrafiltration is also used for the concentration of latex emulsion. Latex, latex emulsion consists of particle about 0.05 to 0.3 pump in size of stabilized by ionic and non-ionic surfactants. Some latex streams such as styrene, butadiene, rubber and polyvinyl alcohol polymerization cattle wash are very dilute. Ultrafiltration is suitable for concentrating this stream amount of 0.5 to 25%. Then ultrafiltration is also used for the pulp and paper industry, textile industry and clarification of juice. So these all are various industrial applications for ultrafiltration. Now let's discuss about various factors affecting performance of ultrafiltration. As discussed in various membrane separation process, there are various factors affect on performance of membrane separation process such as transmembrane flow, then operating pressure and operating temperature and salt concentration. So these all are parameters which affect on ultrafiltration. As discussed in various membrane separation processes, if we are going to increase transmembrane flow, we will get the higher flux, and if we are going to decrease the transmembrane flow, we will get the lower flux or lower permeate. Similarly, if we are going for the increase in pressure, we will get the higher driving force and we will get higher flux for the ultrafiltration membrane. So let's suppose there is one membrane, ultrafiltration membrane. If we are applying higher pressure to the membrane for feed material, then it will be passed fast from the membrane. So it will get a higher flux compared to lower pressure. Then third is our operating temperature. If we are going to heat the feed, we will get the lower density compared to normal density. So if we are going to increase in temperature, then we will get lower density of the feed, and for the lower density it will be easily passed from the pores of the ultrafiltration membrane. So we will get the higher flux in higher temperature. But if we are going to increase temperature beyond the temperature of critical temperature for this ultrafiltration membrane, then there will be chance of cracking in ultrafiltration membrane, and it will be fail during the process. So optimum, it is necessary to run this ultrafiltration process at optimum condition. Then salt concentration is also affect on ultrafiltration. Salt concentration, if we are going high salt concentration in feed side, then there will be chance to accumulate various salt on surface of membrane, and it will be block the pores. So the permeate cannot pass from the membrane. So we cannot get achieve higher flux. So if salt concentration is higher in a feed side, then it will be reduce the flux, and there is also chance for concentration polarization and fouling of the membrane. Then now let's discuss about various methods to reduce concentration polarization. So let's first understand meaning of concentration polarization. So let's first consider this is a membrane or ultrafiltration membrane. This is the pores of the ultrafiltration membrane. Let's suppose these two pores of ultrafiltration membrane. Now, if we are going to pass the feed from feed side to ultrafiltration membrane, feed contain various solute. So, when the feed pass from the membrane, the solute will be accumulate on surface of the membrane and make one gel layer. So this type of gel layer occurs when the solute is accumulate on membrane surface, and this gel layer is known as the concentration polarization. To reduce the concentration polarization, there are various techniques such as the use of tangential feed flow rather than the impact. So we have to apply tangential flow. So if you are going to apply tangential flow, then this accumulation of molecule will be run off, and membrane surface will be clean. So this is one method for the removing accumulate solid particle on membrane surface. Then second method for reduce concentration polarization is introduction of frequent feed flow reversal. So if we are going to apply reverse flow to the ultrafiltration membrane, this molecule will be run off from surface of ultrafiltration membrane, and we will get the clean membrane. So this is about the how the reverse flow works in ultrafiltration. And then third technique, which is the introduction of mixing promoter into the feed channel. So if we are going to add promoters to feed, that main aim of promoter to do not accumulate on surface of the membrane surface. Then fourth technique is that use of frequently pressure pulse of feed flow. So if we are using ultrafiltration, let's suppose this ultrafiltration process is operate at 1 atmospheric pressure. So we have to apply pulsation method. So we have to apply for 2 seconds or 3 seconds. The pressure we have to suddenly increase the pressure 2 atmosphere to 3 atmosphere, so that pulse will created, and due to this pulse the accumulation of the surface of this solute will be removed. Then final method for the removal concentration polarization is addition of dynamic particle to feed stream, which same as the promoter. So if we are going to add dynamic particle that run off this solute, and we will get the clear ultrafiltration membrane. So these all are methods to reduce the concentration polarization. Sometimes chemical methods are also used to reduce the concentration polarization. So in this lecture, we have discussed about the various concept of working of ultrafiltration membrane, where ultrafiltration membrane can pass the water or can also pass the multi-ions and ions and acids, but it will be reject of proteins and polysaccharides and various particles, colloids and bacteria. Then discuss about the various application of ultrafiltration, such as waste in wastewater treatment, treatment of oily wastewater, processing of whey which is a byproduct of cheese. Then it's used for the recovery of electrocoat paint and concentration of latex emulsion. Then discuss about the various factor performance of the ultrafiltration such as the transmembrane flow, operating pressure, operating temperature and salt concentration. Then discuss about the various methods for reduction in concentration, polarization such as the using of tangential flow, introduction of frequent feed flow reversal, then adding promoters and dynamic particle and use of pressure pulse for the feed flow. So this is all about today's lecture. I am completing my lecture here. Thank you.